Hi friends, so welcome to my math question bank number 8, and today I'm going to discuss 5 questions and then I'm going to solve them. These are essentially math questions which you can ask in interviews and also given tests. So these are useful if you are conducting some job interviews for STEM graduates, or they may even be useful for interviews for bachelor's, master's or PhD students. Also, some of these questions will be useful for people preparing for the math Olympiads and so on. I'm Dr. Ganguly. So let's start with a very basic question and a very basic concept in mathematics, which is the quadratic equation. Now, many a time you will see the quadratic equation being used in different situations, and most of us have memorized the solution of this quadratic equation. Now, one very easy and nice question is to ask students to derive this solution, and you'll be surprised that many students are not able to do that. So let's do this particular problem. So essentially the quadratic has the form ax square plus bx plus c equal to 0, and of course a, b and c are constants and x is the variable here, and when we say there is a solution to the equation, there are actually two solutions. So the solutions are x1 and x2, and we need to find these two solutions for this quadratic equation. Now quadratics are very important because even many nonlinear functions can be represented as quadratics in a small region in the vicinity of a certain point and so on. That's the philosophy behind many approximation methods in optimization and in numerical analysis. So let's start with the quadratic equation, and what we are going to do is, again, we are going to solve the problem in blue and the final answer I'm going to give in green. So we take this equation in red and I'm going to divide it throughout by a. So of course I get this equation here, and in this process I'm also assuming that a is not equal to 0. Of course, if a is equal to 0, you would simply have the equation bx plus c equal to 0, which is a very trivial equation which most people can solve. So now let's look at this equation here, and what we do is that we take the c by a term to the right hand side, so it becomes x square plus b by ax equals negative c by a. Now the trick here is to understand that the left hand side of this equation could be expressed in the form where you can express it as a square. So to do that, if we think that there is a x square term, there is a term involving x, then there should be a constant term also that's going to help us square this particular left hand side. So what we do is that we add b square by 4a square to both sides of this equation. That's what I have done here. And the reason I'm doing this is that the term here is essentially the square of x plus b by 2a. So you can clearly see that if we do that, then we will get x square, we will get a term involving b by ax, and we will get a term involving b square by 4a square. So this is the key step here, this addition of this extra term, which essentially lets us form a perfect square, and then we can get this equation here. So on the right hand side, what I've done is I have consolidated the two terms here. There is a 4a square in the denominator, and in the numerator I get minus 4ac plus b square. Now I can take the square root of both sides of this equation, so I get x plus b by a is plus minus 1 by 2a, and this square root term, which is b square minus 4ac. So b square minus 4ac has come here. The 4a square has got subject to the square root, and it's become 2 by 2a. Now at this point, what I can do is I can take the b by 2a term to the right hand side, which I do here, and so I get x is minus b plus minus root b square minus 4ac by 2a. Now most students have this committed to memory, or they should have it committed to memory, because quadratics crop up every now and then and you need to know the solution, but now you also know how to solve this problem. Now many a time if you are conducting a particular interview, you may ask some problem where a quadratic is involved and a person may just use this equation, and so the next question could be that you can ask them to derive this particular equation. That's a very interesting follow-up question. Now let's come to question number 2, and here I am going to introduce something known as a functional equation. So essentially this is an equation where I have been given f1 by x is a certain value here, and what we are told is that we have to find this function f of x. Now this is a relatively easy functional equation. Later on in this lecture series I am going to discuss more complex equation, but let's start with this equation here. It's also mentioned that x is greater than 0, so this is an extra piece of information which has been given to you. So let's start with this question and let's try to solve it. Now, one of the ways to solve the functional equation, and I think this is the simplest way, is to declare this 1 by x as another variable. So whatever is there inside this function, we can say this is some variable u. So we define u is 1 by x, and again remember that x is greater than equal to 0. So if we look at this equation, we will clearly see that u will be also greater than equal to 0 if we substitute into this equation. Now from this equation I immediately get that x is 1 by u, and so I can substitute that here. So f1 by x simply becomes fu, then the term involving x becomes 1 by u, and also I get a 1 plus 1 by u squared term here inside the square root. Now what I can do is I can simplify this. So I can take the u square common in the denominator, and so I will get 1 plus u square on top. So this is something which we will get here. Now once I get this equation, what I can do is that I can take u square out of the square root, and since I have been already told that u is greater than 0, there is going to be no plus minus u here. It's simply going to be plus u. So I get fu is 1 plus root 1 plus u square by u. So you can now clearly see that the functional equation is in this form. Now what we can do is that we can replace u by x, and so we get this as our function which is given here. Now some people find this step rather confusing. They think that how can I replace u by x once I had already replaced u by 1 plus x. But this shows that you have understood the concept of functions. When I have a function in this form, I can always replace u by another variable x. So this is a different variable out there, a general variable out there. And so if you want to of course test this particular problem, you can test it out and see, and you will see that this is going to yield the functional relationship which I have given here. Now let's come to question number 3, which is a very favorite question for many examiners. And this question involves finding the rank of a matrix. Now, rank of a matrix is something which is very important because it comes in useful in terms of solving the equation and so on, in terms of whether the equation is going to be singular and things like that. So many of the important properties of the matrix are related to its rank. So the matrix which I have seen being given quite frequently in various tests is this matrix because it's very easy to write. So essentially you can write 1, 2, 3, 4, 5, 6, 7, 8, 9, and you can give this particular matrix to the student and ask them to find the rank of this matrix. Now there are several ways to find the rank of this matrix. So I'm going to look at one of these methods in the solution. So the method I'm going to look at is known as the conversion to the echelon form. I find this is a very nice and proper method to actually find out the rank of the matrix. So what we do is we start with the matrix and then we perform various operations on its rows, and the aim here is to actually reduce it to what is known as the echelon form, which is that it should have a form where there is a triangle of zeros in the lower half. Now do remember that the fundamental definition of rank of a matrix is that it is the number of linearly independent rows or columns in a particular matrix. So of course there are going to be situations where the matrix is such that you can figure out that by just looking at it, but in this case it's not so simple. You can see that it's somewhat difficult. Of course if you have a solution you can leave it in the comments, but I will try the brute force method, which is I am going to try to reduce this matrix to the echelon form. So let's start the process. So I can see here, if I use the particular relation, R2 is R2 minus 4R1, okay, where R stands for the rows, then what will happen is that I will get a zero term here in the second row. So I have selected this R2 minus 4R1 because I'm going to get 4 minus 4 into 1. So this term is going to be 0. And so the result on these terms is going to be again that this is going to be 5 minus 4 into 2. So that is going to be uh, 5 minus 8, and that gives me minus 3. Then I get here 6 minus 4 into 3, that is 6 minus 12, and that gives me minus 6 here. So, and here again I get 7, 8, 9, which was there before. Now this is a procedure which many of you are familiar through how to simplify determinants, so that's what we are doing here. Now the next thing I'm going to try to do is bring this 7 term to 0. So to do that, I use the relationship R3 is R3 minus 7R1. So again, this term immediately becomes 0. And what happens is that these terms also change. So this term is simply going to become 8 minus 7 into R1 minus 14. So that's going to give me minus 6 here and minus 12 here. Now again, I need to subject something to an operation such that this last row is simplified. So what I'm going to do is I'm going to try to bring this minus 6 term to 0, and for that I put R3 is R3 minus 2R2. So I can see here, if I do that, then this term becomes 0 here, and interestingly this term also becomes 0. So I get this particular matrix, and now the matrix has reached the echelon form, which is I have a triangle of zeros here. Now what I can do is now I can use the fact that the rank of the matrix is the number of non-zero rows in the echelon form. So here you can clearly see that there is one row which is completely zero, and then there are two rows which are non-zero. So the rank of this matrix is 2. So this method is a very nice and proper method. Of course, there is also a method of taking determinants, minors, and so on. Please leave in the comment section as to which is your favorite method to find the rank of a matrix and why that is so, because this is a question you can very often expect in many interview situations. Now let's turn to question number 4, which is actually a problem in some math Olympiad, and this is a good problem. Even high school people can solve it. So many of the problems I actually discuss can be solved at the high school level, and you don't need to essentially go to college to solve them. So this is a good review of basic math. So the question here is that a plus 2ab plus b is 8, and what is a plus b? That's something we need to find. And also it's mentioned that a and b are positive integers. So essentially this z or z is used to particularly represent the fact that these are integers. That's coming from the German Zahlen, I think, which means to count. So let's try to solve this problem. Of course, you can see that this is a problem where there is one equation, there are two variables. So there may be many solutions out there. We may not be able to find an clear solution, but let's see where we can get to in this equation. Now, here one of the important things to realize is in these kind of problems, you have to keep manipulating things till you get some clarity. So one of the things you can see here in this problem is that maybe you could factorize the left hand side of this particular equation. So that's what we are trying to do here. Now to do that, what we do is we first multiply both sides of the equation by 2, which I have done here. So this 8 has become 16, and then I have the 2 here. Now I expand the left hand side, so I get 2a plus 4ab plus 2b equals 16. Now what I can do is that I can take 2a out, and so I get a 1 plus 2b term, and again I get a 2b term here. Now I can add 1 to both sides of this equation, then I would get 1 plus 2b terms here, and I can factorize this equation. So I do that, I take this equation, I add 1 plus, I add 1 to both sides of this equation. So when I add 1, I have got this 1 plus 2b here. This has become 1 plus 16. And so then I can take 1 plus 2b as common. Remember, outside this there is a 1, so the other term becomes 1 plus 2a. So 1 plus 2a into 1 plus 2b equals to 17. So now by representing it in this form, I can clearly see something which is very interesting, that the right hand side is actually a prime number. Now you know, with 17 being a prime, you can only write it as 1 into 17 or maybe as 17 into 1. So let's think of 1 into 17 first. So in that case, what would happen is that 1 plus 2a would be 1, 1 plus 2b would be 17. And I can solve 1 plus 2a equals to 1. I will immediately get that a is 0. If I solve 1 plus 2b is 17, I get that 2b is 16 and therefore b is 8. So a plus b equals to 8. Now if I were to consider 17 is 17 into 1, I could say 1 plus 2a is 17, 1 plus 2b is 1, and then I would get a is 8 and b is 0, but I would still end up with a plus b equals to 8. So we have solved this equation. This is an interesting equation because it tests some of the algebraic principles, and it also shows you the importance of prime numbers. So once we can show something is factored and on the right hand side we have something related to prime numbers, we can actually get something out of that particular algebraic problem. Now let's come to question number 5, which is a problem related to geometry. And here the problem is that we have a circle. Inside the circle there is a triangle, and this triangle is such that the area of these particular smaller triangles, that is ACD, is given as 64 centimeter square, and of BCD is given as 16 centimeter square, and we have to find the area of the circle. Now looking at this problem, of course, you know that to find the area of the circle, we need to find the radius or the diameter of the circle. So let's think about the diameter. So if we were to find this particular length AB, then we can simply find the area as pi d square by 4 using the formula which is very well known. So let's try to solve this problem. So first thing I do is I give some nomenclature. So I call this height h, I call this distance a, I call this distance small d minus a. So small d here refers to the diameter of this circle. Now here a very important thing which you have to use is something known as Thales theorem. This is a very old theorem. Thales was a Greek mathematician, and this is around the time of Euclid and so on. And his point was that if you have a circle, and let's say we have a semicircle, and if we put a triangle here, this triangle ACB, then this angle ACB is always going to be 90 degrees. So essentially any such triangle is going to be a right angle triangle, right angled at ACB. Now this is going to help us to use Pythagoras theorem several times in this problem. Now the information which is given here is the area of each of these triangles. So let's take this one first, that is ACD, and here we can write that 64 equals half HA. Now that's the formula for the area of a right angle triangle, and you can immediately see that if you were to create a rectangle here, that would be h into a, so the right triangle would be half HA. Similarly on this side we get the equation 16 equals half h into d minus a. So we got two equations here, but we have three variables. We have h, a and d, so we need one more equation, and that equation comes from the fact that Thales theorem tells us that ACB is 90 degree. Therefore I can write that AB square is AC square plus CB square, that is AB square here, which is the diameter square, is AC square, one side square here, plus CB square, this being a right angle triangle here. Now what I do is AB square is simply D square. Now AC square itself is actually H square plus A square, again using Pythagoras theorem, and CB square here is again H square plus D minus A square. So I get this equation here. Now I can expand this right hand side here because I can write d minus a square is d square minus 2ad plus a square. Now what I can do is I can do some cancellation. So you can of course see that the d square here and the d square here are going to cancel. So I'm going to get 2h square plus 2a square minus 2ad equal to 0. So let me cut out all those 2's, and so I can write h square plus a square is ad. So that's the third equation I have got. Now what I have to do is to solve this equation, and this equation, and then I should be able to get h, a, and d and solve this problem. So let's start by looking at this equation here. I can write it as d is h square plus a square by a. So we are going to come back to this equation after a few steps. Now let's look at these two equations here. So from this equation here, 64 is half HA. I can immediately write H is 128 by A. Remember 64 into 2 is 128. Now the next equation I get is from this equation here. So I get 32 is H D minus A. And then let me substitute H from here. So I get this is 128 D minus A by A. So this is the second equation here. Now let me write this equation out again. So this equation will become 32 into A is equal to 128 D minus A. So I've expanded that out. I've got 128 D minus 128 A, and on this side I've got 32 into A. So this equation is relatively easy to solve. I can take a to the left hand side, and after doing some simplification I can get d is 1.25a. So you can verify this with your calculator on your phone or on your calculator actually. Now I've got at least now one equation which gives me a lot of clarity that the diameter is 1.25 of a. Now what I can do is I take this equation and I substitute it in this equation. D is h square plus a square by a, because we have not touched this equation yet. So here I can immediately write D is 1.25a. So I get 1.25a. I bring this a from the denominator to the left hand side. So I get 1.25a square is h square plus a square. H square I replace by 128 by a square and a square. So now I have an equation with only a there, and now I can try to simplify this. So essentially if I bring a square here, I'll get 0.25 a square, and this will be 128 a square by a square, and then I bring the a square to the left hand side. So I'll get 0.25 a4 is 128 square. Now I can solve this equation very simply using a calculator by taking square roots repeatedly, and I will obtain a equal to 16. Now you can verify this on your calculator, and once I get a is 16, I can immediately get h is 128 by 16, and that's going to give me 8. And then I can get d is 1.25 into a. So that's 1.25 into 16. That's going to give me 20. So that was the whole aim of this math, that I now got the diameter of this particular circle. And so I can now invoke the formula a is pi d square by 4. And I can immediately get the value by substituting d is equal to 20. So that will be pi into 20 squared by 4. And if I use the value of pi, I get this to be 314.16 centimeters square. So that's the area of this particular circle. So this is an interesting problem because it tests your knowledge of some basic geometry, of some algebra, of the Pythagoras theorem, and also some manipulation of various algebraic entities, which is going to test your meticulousness as far as your math is concerned. So these were 5 questions I had for you today, and I hope you enjoyed this exercise. And I of course suggest that you always do these problems first and then try to see the solution. And certainly you can use these problems in various tests. You can also use them in preparing for competitive exams or preparing for your class tests in high school and college, and generally to improve your general knowledge of mathematics, because mathematics is something which you should have at the tip of your tongue and the tip of your brain, and any math you learn actually helps to improve your IQ, so that's going to certainly help you in life. So I'll end now this video now, and I will see you in a video sometime soon. See you then.